Fourth grade lesson 7.5 is add and subtract fractions. Let's have a look at this lesson. Our essential question is, how can you add and subtract fractions with like denominators? So we're still dealing with denominators that are the same. Our pizza is being cut up in the same way, so we don't have to do any manipulations on that. We're now just adding and subtracting without use of the models, but hopefully with the previous two lessons, you won't need the models anymore. We'll unlock the problem. Julie is making a poster for a book report. The directions say to use 1/5 of the poster to describe the setting, 2/5 of the poster to describe the characters, and the rest of the poster to describe the plot. What part of the poster will she use to describe the plot? So keeping in mind that the whole poster is being cut into 5 equal pieces, because that's my denominator, we're going to shade 1/5 of the poster to describe the setting, because that's the first piece of information that they gave us. So we'll shade 1/5 of it. Then we will shade 2/5 of the poster to describe the characters. So 2/5 for the characters, 1, 2. So we shaded 1/5 for the setting, 2/5 for the characters, and then write an equation for the part of the poster used for setting and characters. Well, we did the 1/5 for the setting and added to it 2/5 for the characters. So as an equation, that would be 1/5 plus 2/5, and that equaled 3/5. What does the part of the model that is not shaded represent? This is the not shaded part, and this is representing what's left of the poster, right? How much of the poster is left? And they'd like for us to write an equation for the part of the poster she will use for the plot. Well, we started with the whole poster, 5/5 or 1 whole, and we subtract from that the part that's now been used. All 3/5 of this has been used already. And that is going to equal how much I have left to use for plot. I can rewrite this too, just in case you want that common denominator. 5/5 is the same as 1. Then I'm subtracting the 3/5 that we already used. What's left, the 2/5, can be used for plot. So she will use 2/5 of the poster for plot. What's the error? Luke says 1/5 plus 2/5 when he did this addition up here equals 3/10. What is his error? What mistake did he make? You may be noticing that his denominators, they were cut into 5 pieces, and now suddenly they're cut into 10 pieces. When we add fractions, we don't change the denominator. The way it's cut is still the same, and I'm going to give a visual for that too. So we had, in picture form, it's cut into 5 equal pieces, and we had 1/5, and then we add 2/5 to it, and we know it should be 3/5, 1, 2, 3 out of the 5. He says it's 3/10. 3/10 does not look like this. This is 3 out of the 5. 3/10 will look like this. And that's different, right? That's much less than this. So he tried to cut these even more into tenths. No, it stays cut into fifths. We're not cutting the pieces up anymore. We're just talking about how many are already there. So when we add or subtract fractions, don't add together or subtract from the denominators. They stay the same the whole way through. It changes later with multiplication, but for addition and subtraction, your denominator needs to be the same. The way it's cut up needs to be the same. So my answer for number 1, what's his error? He added the denominators. You keep hearing me use the term common denominators. Fractions with common denominators, the same denominator, represent wholes that are divided into the same number of equal-sized parts. To add or subtract fractions with the same denominator, you can add or subtract the number of parts given in the numerators, and the denominator doesn't change. So we have 1/4 size part, and we're adding 2 4th size parts. How many 4th size parts will we have? 1 4th size and 2 4th size is 3 4th size parts, and here it is calculated. 1/4 plus 2 4ths. We still have it cut into 4 equal pieces. That stays the same, but I get 3 4ths that I still have. 3/6 parts, 3/6 size parts, added to 2/6 or 2/6 size parts. I have 3/6 size parts and 2/6 size parts for a total of 5/6 size parts. And here it is over here, 3/6 plus 2/6. They're cut into 6. They're going to stay cut into 6 equal pieces. 3 plus 2 is that now I have 5 out of the 6 equal pieces. 7 tenth size parts minus 4 tenth size parts. I'm taking the 7 tenth size. They're all both tenth size parts, equal sizes. 7 minus 4 is 3 tenth size. Well, not that. That's not right. Not tenth size. It's tenth size. And this is 7 tenths minus 4 tenths equals 7 minus 4 is 3 tenths. And that's pretty much everything this lesson is showing us. So we'll do the share and show to make sure we're understanding this completely, and then I think you'll be ready to go off on your own to Think Central. We have 9 12th size parts minus 5 12th size parts. 9 12ths minus 5 12ths. Common denominator. 9 minus 5 is 4 12th. Not 12th. 12th. That's hard to say. 12th size parts. And so in numbers form, that's much easier. 9 minus 5, 4. I have 4 12ths. Okay? We have 3 12ths plus 8 12ths. How many 12ths will there be after I do 3 plus 8? 3 plus 8 is 8, 9, 10, 11 12ths, almost all of it. Here I have 1/3 plus 1/3, so they're cut into 3 equal size parts, and we're going to leave them cut into 3 equal size parts. I get 1 here, and then another one there for a total of 2 out of the 3 equal size parts, 2/3. 3/4 minus 1/4, it's already cut into 4 equal size pieces. 3 minus 1 is 2. The answer is 2/4. 2/6 plus 2/6 were cut into 6 equal sized parts, so we're going to end up with 6. 2/6 plus 2/6, 2 plus 2 is 4/6. Here we have 3/8 plus 1/8. It's already cut into eighths, so that's good. I have 3 of those eighths, and then I get 1 more of those eighths for a total of 4/8. 3 plus 1 is 4. Finally, I have 6 tenths minus 2 tenths. So they're already cut into 10 equal pieces. I have 6 of those tenths, and now you're taking 2 of those tenths away from me. 6 minus 2 is 4. I'm left with 4 tenths. And let's look at one word problem. A city worker is painting a stripe down the center of Main Street. Main Street is 8/10 of a mile long. Stop right there. And let's go ahead and draw Main Street. Main Street. And it is 8/10 of a mile. So I'm going to do Main Street split into 10 equal pieces first. And that would be 1 whole mile. But Main Street is only 8/10 of a mile long. 2, 3, 4, 5, 6, 7, 8. And the worker painted 4/10 of a mile of that street. So he painted 4/10, 1, 2, 3, 4/10 of a mile of that street. Notice I drew the picture when I'm not sure what I need to do. I draw a picture. I always do. 4/10 of a mile street. Explain how to find what part of a mile is left to paint. Well, I'm looking at this and I see this much is what's left to paint because that's as long as the street is. I'm going to just circle that whole amount there instead of a bracket. That's how much is left. So how can I explain what calculation I need to do to find that? I started with 8/10. I started with 8/10. That's how long the street was. And he already took care of 4 of those tenths. So 4 of the tenths are already done. So I can get rid of them because they're already done. And to get rid of them would be subtract. Take 4 of the tenths out because he's already done them. So how much is left to paint? Oh, okay. Well, still split into 10 equal pieces. 8 minus 4 is 4. He still needed 4/10 left. So I would explain in a math calculation or picture form Or you could just explain in words. Take 8/10 and subtract 4/10. That's it for this lesson. I think you're fine to go forward on this. Let me know if you need additional help.